So we've got this homework outstanding here, and it's about block cipher modes. And you could do this completely on your own. Let's just read the question here, but I'm going to give you a lot of help. So this question concerns block cipher modes. We'll use a simple affine cipher. So here, this is an affine cipher, but the the A term has been fixed at 11, and then the key is really B. In the language of the affine cipher, as you probably don't remember from like the first day of class 6 weeks ago. Note that the block size is 8 bits. So this is supposed to be a block cipher. A block is just a character, which is 8 bits. That's 1 byte or 1 ASCII character. And everybody knows their ASCII characters. Let me just remind you here. So you should be very familiar with this table. I know not everybody is, but so every character is some hexadecimal number. So I'm going to be using those encodings. So great. So we'll work with a fixed key, which is 0x08. So this key is actually always going to be 0x08. So this is just a fixed transformation. And you can invert this to come up with the decryption mode of the block cipher. I've already done that for you. So we now encrypt various plain texts using modes for this cipher. You have to implement the mode. I'm going to assume we're going to implement it in C, but if you prefer to do this in Python, then you certainly can. So in every case in which the mode requires an initialization vector, we're going to use OXAA. And in the case of CTR mode, the thing that goes into the cipher is going to be the nonce concatenated with a counter as described in the textbook. And we're going to use the left 5 bits of the initialization vector on the left side, and then the remaining 3 bits will serve as the counter. So this block cipher in CTR mode can only count up to 8, but it kind of tells you something about counter mode too. Every counter mode has an issue like that. It's just that they're usually like, 32 bits or something for the counter instead of 3. And all of the problems given below, one character is one block. Each character of the plaintext should be regarded as its corresponding ASCII code. All right, so let me show you the code that I've written here, and I'll just clear this. So here is, you can ignore this advice at the top. It used to be that you had to have the supplementary stuff to compile this, but it's not really true anymore. Okay, so here's the cipher. That's the same as in the homework assignment. And here's the inverse. So the decryption mode, saved you the trouble of doing that. And now there's just some placeholders for these other functions that you're going to implement. So here's OFB mode. ECB mode is very straightforward. So just to show you how it works, I'm going to go ahead and give you those. So there's ECB encryption and decryption. How does ECB mode work? You just go through and you encrypt every character independently. This kind of shows you how it works. We're getting an array here, which is just a pointer to the first entry in the array. And when you go through and you do this, it actually changes changes what's in that memory location. So this has an effect back in the calling function. And here's decrypt. So here you just do the inverse transformation on each character. Here we call this PT and here we call it CT, but the code actually, doesn't care what you call it. It does the very similar transformation to the array in both cases. And over the years, I've decided that CTR is just too hard for students to do. And so I'm going to do it myself. What this does is this restricts the IV to its leftmost 5 bits, and then you concatenate the IV and the CTR and apply it to the cipher with the key, and that's part of the key stream, and then you XOR in that part of the key stream, and then you update the counter. Okay, and what this does is it restricts the counter to its rightmost 3 bits. But that was blowing students' minds. Something else that I've found over the years, this is, unbelievable. But a student will go to implement like CBC mode and they'll say, oh, well, I already have this code for CTR mode. I'll just copy and paste it into CBC mode, which is like laugh out loud bad idea. And I hate to say it, but a lot of you will probably use ChatGPT to cheat on this now. So we'll see what happens. Please don't do that. It's better for your own learning if you can actually implement these things. But let's just, one thing ChatGPT could do, though, is explain this code and answer your questions about it. But don't even touch it. It's evil. Let's not get into a deep discussion of ChatGPT here. It has pros and cons. For most of you, it's ruining your lives and making you completely ignorant and unemployable. Okay, so let's look through here. Here we fix the key. Here's the initialization vector. And I picked this as plain text. Why did I pick that stupid word? Because over here, I'm going to do some of this assignment. This is my assignment. Everybody has a different one. So it says encrypt the plain text Lippy using ECB mode. So I'll just show you how you would do that. So I've set the plain text to be Lippy here. This is just getting the length. So the length is, 5, I guess. And this calls the encryption function. The plain text gets overwritten, which commonly happens in cryptography because you don't want the plain text hanging around in memory. And then this just goes through and prints every character. Okay, so let's see how it works. So I'll do gcc modes.c. If you want to compile this some other way, it's fine. And what comes out is this. And down here, I've shown you how to use the decryption mode. Actually, I made a mistake here because see how this is Lippy with a Y? Actually, I had to shoot this video twice because I confused myself about that. So notice that this is 8B, but this is 3B, which is why, anyway, I don't want to be, that's confusing. So let's just take this and we're going to come back to this assignment and we're going to paste it in here. We'll take out these spaces and then we'll check our answer and it's correct. Okay. And we could also do CTR mode. How would you do CTR mode? Can we figure that out? So CTR mode actually does it take the same number of parameters? It takes the plain text, the key, the IV, and the length. ECB does not take an initialization vector. So if we were going to do this in CTR mode, we would do CTR, plain text, key, the initialization vector, and the length. The signature is a little bit different. And then we definitely need to take that out. And now let's go back to the assignment here. What are we supposed to encrypt in CTR mode? LiPo. So I'll go change this to an O. And then recompile and run. And we get this. And let's see if that worked. You have to take out the spaces. Okay, that's correct too. All right, so now all you have to do is implement CFB, CBC, and OFB. All right, let's go to the next problem. All right, so this next problem is very similar, except now you're going to be doing everything in decrypt mode. Oh, look at this. I gave you the inverse. I forgot that. Okay, so note that the block size is 8 bits. I think that's actually all the same boilerplate from last time. So it says decrypt this ciphertext, and that's the same as encryption, right? So we should be totally ready to go do this one. Let's come over here. Now there is an issue, which is on a Mac. This is very annoying. I'm just gonna put this here. See how it pastes in the italics? Now, those are not UTF-8 characters anymore, which adds an extra layer of complexity. You have to be really careful. So as everybody / nobody learned in 271 and 272, if you want to enter hexadecimal, this is how you do it with these \x escape characters. So I'm entering this as hexadecimal. Probably going to make a mistake. Hex 1 2. Okay, and now now it's going to run CTR mode, and it's unfortunately going to print out everything in hexadecimal. So I'll do that. And now here's the answer, but it's in hexadecimal, whereas you actually want that to be in ASCII. How could you do that? Well, you could just use this print statement. Actually, this is the form of the print statement that we probably should use. But instead of doing that, I'll just copy this, and I'll come down here and I'll put it in here. So suppose the ciphertext we want to decrypt is this stuff. Paste it in. I made a mistake, so I'll get rid of these extra quotes. How long is this thing? 1, 2, 3, 4, 5, 6. I'll change this to 6. And now I don't want to do ECB decrypt anymore. I'm just going to do actually exactly this line. Except that I need to call this CT. And okay, so now let's compile it and run it. And it says noodle. Oh, that's funny. The plain text turned out to be noodle, guys. So I put in noodle here and check my answers, and it's correct. Okay. And let's also do the ECB mode decrypt. So I'll copy this, come back over here. Paste it here. Transcribe it here. You can actually see how bad ECB mode is just because you can see the repeated characters. And so now what do we, oh God, I did it again. I don't want to put that there. I want to put it down here. I'll copy this, come down here. I don't know what's going to happen up at that top part. As long as it doesn't stop the program from compiling, I don't care. Put that there. What is the length now? 1, 2, 3, 4, 5. The length is 5, so I'll change this to a 5. Put ECB decrypt back on. Turn off the CTR mode. Clear. Recompile. Run. Oh, it's oodle. It's oodle. So I'll come back. And hopefully this is correct. Noodle, oodle. Yes. Okay. All right. And so you do all of the rest of these. You have to do CFB, CBC, and OFB. And all right, that's your job.